the bonding and earthing thing, it's quite annoying because the basic concepts are really, really simple, and yet loads and loads of people just get it completely wrong, and there's just complete lack of understanding.
It doesn't help that it's the hazards in the use of earthing and bonding is increasing. And I think one thing we probably hit on is configuration is key. Know your earthing system, know the rules of your earthing system, and how you configure your bonds.
Yeah.
Shall we? Okay.
Sorry, my Discord's just gone up.
Wait. 32, 41, 16, all the fours, 44. Hello, everybody, and welcome back to the E5 podcast. I am your host, Paul Meenan, and I'm joined by the usual chaps. Introduce yourself.
Hello, I'm JW.
And good evening, it's David Watts here, aka Sparky Ninja.
Right, so lads, we have had time to get coffees and teas, and this is not the same day, and I'm not wearing the same t-shirt as I was in the last one at all. We have done some podcasts on the fundamental issues and challenges around the earthing of an electrical installation. If you want to know anything more about temporaries, please see Mr. Watts 7909 webinars on his YouTube channel, which we'll put a link to. But we're going to talk about bonding, also known as equipotential bonding, or as I like to call it, equal voltage bonding, because that is what equipotential means. So there are no fancy words on these podcasts. It's plain English. And for those who are not aware, bonding is a means of a protective conductor providing equal voltage bonding. Every time I say equal voltage, just think of the word equipotential. But I just don't like using that term. So Dave,
it's a strange word, though, isn't it? Bonding.
It's an old word from an old boys club.
We should have a different word for it now, I think.
Listen, the first time I heard of the word bonding, I thought, oh, we're all going to make friends.
It does sound like that, doesn't it?
It does sound like that. It does sound like, let's all bond. Great. I don't know you. Who are you? Oh, you're a weirdo on site. No, I didn't mean that bonding.
I think in the simplest term, it just means connect that to that, but it doesn't grasp on the actual need, actually what it's for.
But it does. And that's the simplest thing. It is connect that to that. Equipotential means equal voltage. So connect that to that so that any voltages that appear are equal. It's really simple. And if you imagine you're in a building, anything in that building that can conduct is going to sit in one of two pots. One is exposed, which is part of the installation, should be a naught potential or 0 volt potential, and will become live in the event of a failure. The other pot is your extraneous, which is not part of the fixed installation, generally at earth potential, and could become live in the event of a fault. Okay, so there's two pots there. It's the rule of three. I always use the rule of three. Break it down into three concise things. So if you connect that to that, and it's equal voltage, and it's exposed to exposed, which is done via the main earth terminal or the earth bar, or extraneous to extraneous, which could be via a supplementary bond, or exposed to extraneous, which could be via a equipotential bond, and any configuration of them. So again, three ways of doing it.
Those three configurations are given, I think, in BS 7671 under supplementary. It says when it's exposed to extraneous, exposed to exposed, and extraneous to extraneous.
Yes.
So
it's another rule of three. So if you want to learn about earthing and bonding, just remember the rule of three for exposed, extraneous, and how and what you need to bond, because there is three logical parts to those three areas to learn on bonding and exposed and extraneous. It's very, very simple. As an industry, we've kind of thought earthing is bonding, and it's fair to say in our experience we've seen it. We've seen it at trade shows. We've been asked those questions. Earthing is the connection of a fixed installation to the general mass of Earth, so that it's safe in the event of fault current. There is a low impedance path through energy to allow sufficient fault current to blow a fuse, trip a breaker.
I think the question of, is this an exposed conductive part? That's fairly easy for any electrician to decipher, because either it's going to be class 1 or class 2 construction. Some class 2 equipment may have exposed metallic parts, but they won't be considered, obviously, necessarily conductive parts because of the construction of the equipment.
Yes.
I think the bigger question really is extraneous conductive parts. Some electricians will look at something, maybe a bit of furniture in the workplace, and they're like, that kind of gets the question. We know that the obvious things, the gas, the water, the door frame, the window frame might be construed to be extraneous. We know of the tests that's been suggested. Obviously, is that in Gaius Nosates? The 23 kiloohm or the 22 kiloohm example, John's nodding. Is that in there? I've not looked in there.
I think so.
That's
somewhere in here, yeah.
To decipher if it is or is not an extraneous conductive part. But I think that's the area really that's kind of left a gap in understanding, or maybe a bit of guesswork down the line as to whether something is or is not an extraneous conductive part.
So years ago, and I'll throw myself under the bus here. Years ago, I was taught. Maybe this is, I don't know, maybe this is a forgotten thing, that if you put your mega across a piece of, you put one probe on the exposed part of an installation, i.e. a light switch, and you then put the other probe against another piece of metal that wasn't part of the installation, and you did an insulation resistance test, if the reading was below 50 meg, you would consider it bonded, equipotentially bonded. If it was above 50 meg, you would then have to take some form of protective bonding to ensure that the touch voltages between exposed and extraneous would not give rise to harm. Now, I can't remember where any of that is written down. It was one of them rules that was tattooed onto my brains.
Yeah, I think
many years ago.
One of the key things that we need to definitely highlight is, you just said touch voltage there.
Yes.
So we need to make sure we're not looking at every single thing that is metallic in a workplace. We're looking at things that are readily accessible by a worker in the workplace while they're using an exposed conductive part.
Yes.
Did you agree with that?
Yes. And it's probably worth noting at this point in the podcast that touch potentials, or the principle or the phenomena known as touch potential, is managed in modern electrical installations via automatic disconnection of supply of a breaker within a prescribed time. And that obviously is relevant to ZS tests. Main equipotential bonding is another way of managing it. Also supplementary bonding as well, where deemed required. Now, supplementary bonding, as we were growing up, was mad. Years ago, if you go back to the 15th edition, you were bonding metal door frames, metal windows. You had cage bonding.
I remember my apprenticeship.
Everything was connected together.
I remember my apprenticeship. My granddad had a specific hammer, and he said, "Don't hammer with that hammer. That's not for hammering." I go, "What's it for then?" It's got the perfect dimension of the handle for you to wrap your protective conductor around for your little coily supplementary bonds, because we had a commercial kitchen at the racecourse, and all of the equipment, all the furniture, like all these shelves and stuff, were actually going to have electrical equipment put on them. So we were told to bond them, but they were always being moved around. And every year we'd be rewriting the approach to supplementary bonding, and the regulations would do the same.
Yeah, that kind of thing was a complete pile of nonsense, really.
Yeah.
The point here is that in terms of bonding things, you definitely do not want to go bonding things just because they're metal, because if you do, you could actually increase the danger and the risk by bonding things that don't actually need to be. And if you think about, say the more obvious one, say a metal pipe comes in your building, you're going to bond that because that pipe is coming in from outside. It's probably buried in the ground, introducing that earth potential into your building. So you're going to bond that to keep it the same voltage as the other things inside. But if you just had a bit of random copper pipe screwed on the wall, you're not going to bond that because it's not bringing anything into the installation. It's not connected to the ground outside. But if you then connect a big piece of cable to it and then connect it, it is now connected to something. So you've now created a potential there where you didn't have one before.
I've never seen it drawn, but there's a curve, isn't there, really, where you're gradually improving safety. But if you overbond, you've now shot that safety downward.
Yeah.
Because you've created more reference points for fault current to flow, and you've created ones that were never there to begin with.
Yeah, and the 15th edition particularly wasn't it wasn't actually terribly written, but there were certain bits of it which were written in ways that could be interpreted in you must bond everything that's metal, such as bond your window frames and bond the bath and bond the cutlery in the drawer and all that kind of nonsense. So, yeah, it was a bit of a disaster there.
So let me just put a diagram via the magic of screen sharing. So hopefully you should see, John, you've started something now. So this is a nice visual aid for those who are watching on YouTube. Apologies for those listening in the van. But what we have, please tune into our YouTube, is a nice diagram of a human being that shows what happens if extraneous conductive parts are not bonded. So you start off with the kettle. You can very simply see, by the way, I love the old red and black, just shows how old the photo is, but the principle of protection is the same. The kettle that is earthed has become live due to a fault. Okay, so what then happens is a shock current from the man who, for some weird reason, is holding the kettle and the tap. The shock current passes through the body when the kettle and the tap are touched simultaneously. The incoming water supply provides a much more effective path than the installation earth electrode, i.e. a very small CPC of 1.5 mil in a flex, rather than a big clunk of lead or copper, which is nicely buried in the ground. Consequently, if the incoming water supply is not bonded, then a dangerous voltage may occur. Now, if they are bonded together, so that kettle is bonded via the CPC into the ground, back to the primary source of earth, and there was a bond there, in theory, this would be charged with voltage, and at the same point, this water pipe would also appear the voltage, and the path would not be created through the chap holding both. But this guy has, so there's a very high chance that ventricular defibrillation, also known as a heart attack, another fancy word the industry has created, could cause harm. Excuse me. So yeah, so that's one of the pictures. If we then, let me show the next one, because I think that's quite a good picture as well. Oh, pardon for this. So this is again an electrical appliance that has not been earthed and has become live due to a fault. So as you can see there, there's only a line of neutral there. That kettle's become live. The only path to earth is through the human being. It's a very nice diagram of how and reasons why we earth stuff. And the last one, which is my personal favorite, because it kind of just shows everything in context. The incoming supply and equipment, you can see there, it could be a switch fuse into some sub metering and sub switch fuses, but you may have a copper earthing conductor, i.e. a TT, goes to a main earthing terminal, and any other extraneous incoming services are bonded, looped across where at point of entry to the building, and then other earthing systems like lightning protection. And all that means is if there is any electrical hazards or any faults on the fixed electrical installation, that earth bar will be energized, charged with voltage, and all of the pipework will rise in voltage within milliseconds, hopefully. Otherwise you'll feel it and you'll get quite badly hurt. And I like these sorts of three-dimensional diagrams. So for those who are listening, please check out the YouTube channel, or I'll tell you what I'll do is I'll stick these on Instagram, because I don't think they're on our Instagram. So I'll stick them on Instagram tonight.
Can you get the kettle back up?
Oh, right. Yeah, sorry, mate.
Sorry.
Well, the one with the guy getting a shock? Or...
Yeah.
Okay, 2 seconds.
Because the way the regular, because obviously that's illustrating the bonding is illustrated in there, isn't there?
Yeah, hang on.
There we go. All right, so we've got an illustration here of the extraneous earth path underneath. Yep. So supplementary bonding would often be recommended to that tap to equalize the voltage between the exposed conductive part of the kettle and the extraneous conductive part of the tap. Which means that would not travel across. Now, we've omitted the need for supplementary bonding, however, most of the time, with obviously sockets having RCD protection and that kettle being supplied. So the way the regulations are now written is supplementary bonding could be omitted if we have this kind of protection. What are your views on that? Do you think that that's adequate to rely on device disconnection before? Or do you think supplementary bonding should still be in these situations?
Supplementary bonding. Well, I was always, well, supplementary bonding used to be known as indirect shock protection, didn't it? It was protection against indirect shock.
Yeah.
And supplementary bonding always considered applied thought. Yeah, it required people to actually think as to, do I actually need to bond these two pieces of equipment together? So I'm not joking when I say this, and I've got a photo somewhere. I'll tell you what I'll do is I'll put it on the screen while we're talking. I'm going to close this one down, and I will put the pictures on the screen. I'll try another way of editing if this works. But supplementary bonding, I have seen conduits bushed into trunking with fly leads from the trunking onto the conduit. Supplementary bonding. I have seen pigtails on fixed trunking and tray systems that don't ever move. It's, to me, supplementary bonding, I think the only place I ever agreed with it was the cage bonding in bathrooms. I actually liked the principle of the radiator, the taps, the sink, the light fitting,
Those obviously
all at an equal voltage.
And there's an enhanced risk because obviously
it was an enhanced risk, and most supplementary bonding now is basically really special occasions. And the amount of electricians I meet and speak to, and they go, "Oh yeah, we got a supplementary bond list." You're like, well, there isn't really much call for supplementary bonding anymore unless it's in a special location. And that's because there's the applied engineering logic. RCDs, the use of them, I have always said RCDs in my world of training, when I was training, basic and fault protection used to be known as direct and indirect protection against shock. RCDs were always deemed supplementary protection against indirect shock. Yeah, the only time they were direct was on TT installations, and that was for fire. That was it. We've now moved the rules for some weird reason. Never really been properly explained as to why we've moved them rules, and it's now direct, probably because of the amount of people getting shocks from poorly made equipment. But supplementary bonding, for me, I absolutely despise supplementary bonding in every way, shape or form. And that's purely because I just see so much unnecessary supplementary bonding. However, in a house, I will always say to anybody, in a house, there is no harm in making sure everything that conducts is bonded together, especially if it's a TT installation.
Okay. So in a commercial environment, though, you'd be happy for the RCD to provide that protection?
Oh, you're asking the wrong person, aren't you?
Yeah.
Yeah, you're asking. Do I trust RCDs implicitly? No. If I will trust an RCD when I know my external influences will not compromise the safety of the RCD. If I know external influences will compromise it or the connected load, then I may apply additional supplementary bonding then. However, and if we look at what is bonded, because it does kind of lead on to what's bonded. So what are we bonded? We're doing water, we're doing gas, we're doing pipe work, we're doing ducting, we're doing central heating, air conditioning, structures. All these things are common bonded, so that if there is a fault anywhere within that installation, all metalwork rises and falls. Supplementary bonding nowadays, I don't really see where it would go other than the home, in a boiler cupboard, like a cylinder cupboard, or underneath a sink. And I don't mean in a sink that's fed by a plastic pipe, by the way. I mean, just where does it go? Where's its place? I've only ever really thought the only place it would have is to bond heating pipes to water pipes and the main intake. That was the only thing I ever saw of it. And the gas. John, what's your...
Yeah, for domestic, I mean, supplementary bonding is pretty much gone. And it's mainly because there's not really anything you can connect it to anymore. And then the other thing with RCDs now being so prevalent, one of the changes there is that the vast majority of equipment in your house now is Class 2. So if you actually look around at your stuff in your house, there's very little things now that are actually Class 1 with a big metal case around the outside. It's all plastic encased and it's all insulated away and all the rest of it. And that's probably why RCDs now are so much more prevalent. And this whole idea of, say, supplementary bonding in particular has pretty much gone away because there's not really much you can connect it to anymore. So, like RCDs are now a thing. And, of course, we know about problems with those from other episodes that we've done.
Can we talk about the elephant in the room? And that is the new regulation where the metallic pipes entering the building having an insulating section, a point of entry, need not be connected to protective bonding. That little gem. And so many questions today on Facebook. There was somebody asking the question, do I still need to bond this? Do I still need to bond this? Do I still need to bond this? Firstly, my brain says, well, somebody proved to me the effectiveness of the insulated section. That's my first question in my head. How big is this insulated section? Because if I can bypass it with my hand just by putting my thumb and finger across it, pointless. I want evidence to prove the insulating section.
Yeah, well, we know that John did a sequence of videos testing the conductivity of
you did
water, didn't you, John?
Oh, shut up! Right, over to you, John.
So if you want to explain us a little bit on that,
over to you, John.
Yeah, water in plastic pipes. Yeah, the conductivity of water, as in nice water from the tap, is actually pretty poor. So if you've got a section of plastic pipe with metal bits on the ends, if you actually measure that, it's pretty high. So in that way, having the insulated section in the pipe and you don't need to bond is actually right. But the danger with that is you can't just say that, oh, because of this bit of plastic pipe, all is well, because you've got to actually find out where the rest of the pipes go. So if you've got metal pipes within your house, there's a very good chance that those could be connected somewhere else. They might go sort of under floorboards and contact with the ground or something like that. So, yeah, the thing with the insulated section is correct, but you can't just take that as the only thing and say, oh, yes, well, because there's a bit of plastic, that's fine. You've got to actually test those pipes and confirm whether they are extraneous or not.
If I've got a water isolator and that water isolator has an insulated section on it, what if the bit that comes through the wall, let's say it's plastic on the outside, and then goes through the wall in copper, and then it goes to a water isolator, and that's got an insulated section on it. Now, am I going to get a touch potential across the isolator? Where's the evidence behind this? I'm obviously saying the risk is low, but for me, I don't see any harm in bonding all services that run around the house that are conductive.
Yeah, I think the thing
whether
is,
that's supplementary or main.
The thing is, like we just said with supplementary, however, going to worktops, if we overbond, we create a dangerous workplace. Now, if we were to bond a system that had an insulated section, we would technically be creating more extraneous conductive parts than there were. However, I agree with you that, in my view, think about the electrode regulations. It says there, can a water supply pipe be used as an earth electrode? It goes, if it belongs to a water utility supply company, then no. If it belongs to the owner of the property and precautions are taken against its removal, then you could. Now, if I have a bit of plastic pipe and I'm going, oh, okay, well, that's plastic pipe and that's going to be plastic pipe forevermore, so I'm not going to bond, I might not actually be able to assure that, and it could be replaced for a metal bit of pipe work anytime in the future. You see? And so do I have to now talk to the homeowner to say, make sure that bit of pipe work never changes to copper? Make sure, there's that extra awkwardness that regulation creates. I understand the theory, and I watched John's video when he made them, and I understood all of that. So I understand why the regulation is there, but I think it's created a lot of questions because a lot of people, A, don't understand the actual reason, but B, don't like the regulation in principle.
You've got to be careful with this, and it's the same deal as if you've got the incoming water is in plastic, which a lot of new properties are. That doesn't in itself mean that you don't have to bond. I mean, the house here we're in, this has plastic incoming pipe. It's actually black alkathene because it's old, but all the pipes in the house are metal, and in the house, this is actually a bungalow, a lot of the water pipes in metal actually go into the concrete slab, like in the kitchen, and come up again in the bathroom. So although it's a plastic incoming supply, it's all bonded because those pipes are at various points going underground and coming back up again.
Yeah, it's the same with I did some work on just 6 months ago in a kitchen island. All of the pipe work going into the kitchen went under the ground into the concrete screed. So
so you've got to be very careful. You can't just say, oh, look, it's a plastic pipe, I don't have to bother. You've got to look at the whole lot to see where these things are actually going, whether they are actually extraneous at some other point. Because if they are, then that bonding is going to be needed.
I think one of the key problems is we're being told to look at the services, the oil, the gas, the water, looking at their point of entry. Makes sense. You want to bond it at the point of entry to create that cage as soon as you can. But we need to not ignore the fact that it can then go again under the ground. So, we need to explore the regulation more and rewrite it to actually say if it actually, goes underground again and comes back up within the property, not just at the actual tap.
So for me, if the insulated section regulation is a thing, I don't trust. And the reason being is I've seen too many products on the market that are just fundamentally flawed. Please check out John Ward's videos to prove that theory correctly, because he's tested loads of them. But it's quite clear in actually guidance note 8 on supplementary bonding, and I quite like the wording. It says, where necessary, supplementary protective bonding is applied to an installation or location in order to establish an equipotential equal voltage zone within that particular part of the installation or location. It has the effect of re-establishing the equipotential reference at the location for all exposed conductive parts and extraneous conductive parts that are required to be bonded together locally. This is why, for me, if somebody says, don't bother bonding water, don't bother bonding gas, my brain immediately says, make sure everything in that building is cross-bonded. And if you're not sure, cross-bond it at multiple locations. And that is my advice to anyone who says, I won't bother bonding the water or the gas. Make sure that somewhere in that installation, everything is done up tight. It's all cross-bonded somewhere. And that's always been my view. Because, I mean, I'm my house at the moment, in the next 6 months, I'm going to be getting a plastic water supply. I'm going to be getting, I've already got a gas, but I will still ensure there is cross-bonding. Now, I could do that, believe it or not, via a main equipotential bond at the main earth terminal. Because if I bond them, where does it go? It goes back to a common point. They're linked. So what's the harm? On the serious note, think about it.
If you're in your one equipotential zone, there's no harm.
Yeah, there's no harm. So there's actually no harm whatsoever. In my personal professional opinion, you can either do a cross bond in a airing cupboard, which could get removed, or do a proper bond where it comes into the installation, is labelled up at the main earth terminal, and you can access all the joints for maintenance and checking and testing. But at least you know. And this is why when people say, oh, I'm not going to bother bonding it, I always say to people, just stop and think, what are you protecting for? You're trying to create equal voltages.
Yeah, but that's the one of the things. So, like you get that wording, I'm not going to bother. They kind of think that it's a thing that they can maybe not do, or maybe they should do, when really it should be black and white. And this is something I try to drill into the training that I do. Fundamentally, all this bonding is all about the decision of the value of voltage. The supplementary regulation is actually all about 50 volts. Yeah, IA must be less than 50 volts over ZS or something. And if we actually started stipulating more about the actual need to do that, I do a little audit. I did a duty holder audit at a factory a couple of weeks ago. And they basically said, while we're walking around, because I was actually looking at their lighting, but they actually said, what do you think about the need to bond? And I just went, well, it's easy. Where's someone at work? There's someone at work. Okay, what can he touch? He can touch this, and this. Okay, what's the voltage between that and that, that and that, that and that, and that and that? He didn't know. I go, well, that's the bit that's missing. You get an electrician to actually verify the R2 values and the impedance values between these extraneous and exposed conductive parts. Then using the formula, which is a bit of Ohm's law in BS 7671, he can tell you the exact voltages exposed to that person's workplace. And that's the question of if you bond or not. It's just not taught that way.
Yeah, there's a lot of people trying to look for there's some kind of magic list of things that need bonding, but
yeah, these but not these.
Yeah, unfortunately, that's never going to exist.
No.
You've got to look at each individual thing on its own merits. You can't just say, oh, because it's a such and such, it needs bonding, which is completely wrong. And that's kind of where the 15th edition went a bit out of order. But
so
thankfully, that's gone away now. So.
Can I show everybody what I used to do for projects with regards to touch voltage? So this is a commercial industrial model. If anybody watching this on YouTube wants it, they can have it. I'm going to share the screen. And this was a generic pro forma that we developed to demonstrate compliance with what was Regulation 41162, that said exposed conductive parts shall be earthed individually, in groups or collectively. The following condition for 50 volts or DC 120 shall be met. So what we did was we said, look, this is the scope to identify compliance at a certain location. We then said the purpose of the design was to determine if the maximum touch voltage of the main switch complies with it or not. And then what we did was we then just drew a little box with a potential fault, and it's for anyone who hasn't done this before, the maximum voltage of the switchboard is depending on the ZE, the impedance of the cable R1, the R2, and the fault current level in KA. And then what we did was we worked out a little formula here. This is for a London Underground job, and we basically just said, look, ZE, R1, R2, IFUO. What the basis was, we went and got eventually the formulas. We looked at creating diagrams that showed the earth fault loop. We then got the LSOH armored details so that we could plug this all in. We then did a simplified circuit on TNS, and we then had touch voltage equates to UO equals IF times R2, and I fault equates to IR equals UO over ZE plus R1 and R2. So we then had the measurement at the service head, and what we ended up doing was, if you go all the way down, because we worked it out for each type, and there you go, maximum voltage at the service head there, what all the resistance values were, to the point where we got all the way down was, there you go. So that was on a TNCS supply, touch voltage equated to a maximum of 34.37 volts. So we went away and we did the maths, and we did a staged approach so we could demonstrate it so anybody else could verify and validate it. And we made some assumptions. ZE was assumed 0.05, etc. And this is what we put in so that we could prove our design wouldn't give rise. But what was amazing was 34 volts. You just don't think it would rise to 34 volts, but it does. And it was a fascinating little thing. So if anyone watching this wants this, if you email info@e5group.org.uk, I will send you this Word document. I'll need to update it first for the 18th edition, but I'll send it to you and you can have it for free and play around with it to your heart's content.
Yeah, and I'll just point out that although that might have looked a bit complicated and involved, basically all you've got there is voltage, current and resistance. So it's your basic calculation. So although it looks a bit in depth and whatever, it's just those three values. And if you know two of them, you can calculate the other one. So it is really quite simple.
Yeah, sorry about that. That's probably a little bit over the top for what it was. But London Underground, they always like the ins and outs of everything and every thought and feeling that you could ever possibly have for every type of supply condition. They were the worst of the worst. But it's a very robust document, I think it's fair to say. So yeah, bonding. Any other thoughts and feelings about it? Is there any? What's the hazards of bonding? Do you think there are any hazards in bonding? Because I know of one. I've got an example I can throw out there. Where
other than over bonding, where you're bonding parts that don't need to actually be bonded, creating a reference voltage. For example, in the event industry, we'd have people bond the actual physical structures. When we'd have obviously you'd have a generator supplying an installation, then you'd have a fixed installation, and we tried to keep the environments separate. We either have to keep them separate or connect them together in common bonding. And we'd have situations where people would do neither. And what they do is they then do supplementary bonding on some of the furniture, and we then have a system where actually there was no reference to this system at all, and now that's the only reference in all of the kitchen and all of the area like that. So excessive over bonding does create quite a danger.
I think one of the things that worries me is this term that's in the documents now that wasn't there 20 years ago or 10 years ago, this diverted neutral current, because that to me is something that packs a wallop. Now, it's fairly evident that anything, especially on a PME or TNCS type supply, the bonds, and it does say in many a document, they have to be sized to carry current because of this diverted neutral current issue, which is one of the reasons why we've got 10s and 16s and we have to go through all this sizing rigmarole. But one of the issues that I found, and this is it's a railway specific one, the railway have an earthing and bonding standard, and it's NR NR/SP/ELP/21085, and it's earthing and bonding of 25,000 volt lines. Now, in that standard, it's very clear, because what it does is it talks about the overhead line, which powers the train, but the neutral and the earth are the running rails. So it's effectively, it's a combined neutral earth. Now, one of the principles of bonding is the track will have a black cable with a red end on it. It will connect to the low voltage earth bar at the station, and as the train comes in, the voltages that could appear on exposed or extraneous will rise and fall as the train is in section. So any return energy doesn't create a hazard for the end users of passengers on the platform, any voltages appearing between exposed and extraneous. But those bonds, the black coloured ones, are designed to carry large amounts of energy, 6,000 amps. They're designed to carry 6,000 amps for a very short duration. Now, the bonds are in place to rise and fall voltages as the train comes into a station. But more and more and more, if you have a very low impedance electrode, i.e. a lead water main into a station, and you have a very badly corroded track or a missing or disconnected bond, what you'll find is you have effectively a pen conductor loss in electrical terms, where the traction return is very high impedance, so it will naturally look for somewhere else, aka an electrode next to the track, aka a station. And that genuinely does happen on railways more often than not. And that's where bonding becomes quite dangerous. So in the standard, what they've actually done is the minimum bonding for railways is 16 mil. But that's just a basic CPC. If you start looking into it, as I showed you the other day, Dave, you're looking at 35 and 50 mil bonds. And that's just for lighting columns. And the reason being is because it's designed to carry a level of magnitude of energy for the traction system to disconnect under fault conditions. That's bonding. Okay, so they don't call it equipotential bonding in the Network Rail standards. They call it protective bonding conductor, because it protects against traction energy. It's not just about equalizing voltage. So some bonding systems can actually carry energy.
Yeah, because it's not designed, as we said earlier on, as a indirect protection.
Yeah.
Because indirect protection then became fault protection. There's no fault here. This is a functional protection.
To an extent. To an extent, yes. But what this does, it kind of reiterates the importance of, and I don't know if I've said this in the other, configuration of earthing system, supply system is key, an understanding of that. We've got a problem in our industry because the DNOs are terrible at keeping records and informing and cooperating and coordinating with us. Configuration of bonding is really essential, because I think it's fair to say, with the number of faults on the PME system that we saw the other day, John, that there is highly likely there will be more and more instances of shock. We are now in the golden dawn of EV and hot tubs, where we are now exporting these earthing systems for the functional or for the protection of an electrical piece of equipment, while maybe not considering the fact that we could be exporting a risk, a neutral current which may want to go somewhere else, a touch voltage which we're not managing, a car to true earth touch potential that may not being managed. And it's fair to say, from our good friend Dan, when Dan first started with EV charging years ago, it was, do you rod it, do you not rod it? We didn't have the information if you've got to keep rods 2 meters away from a PME supply when this all started. So, and we've also had a recent report on PME, not on PME, on EV cars, where they were saying about 80% of the installations, near to 80%, were fundamentally flawed.
Yes, that was an interesting read.
It was an interesting read. The trouble is it's down to the industry, and when I say industry, all of us, to apply really logical, sequenced engineering judgment and try and garner all the facts we can.
Yeah.
And for me, and this is why I just say to people, listen, if you want a rule of thumb, long story short, every day of the week I would TT my installations. and I would main or supplementary bond them, regardless whether they're insulated inserts or not. Because at the end of the day of the prosumer is coming, and what matters is safety in our homes. And if we are TTing and we are cross bonding everything in our homes, in theory, we should be, as long as we maintain said earthing systems, we should, in theory, be okay. In theory. But obviously, that's a very generic statement, and I know John will probably hit me next time he sees me for saying that generically. But yeah, what are your thoughts, John?
Yeah, like I said with the EV, this is sort of the early stages of it, and unfortunately, what's in the 76713 EV at the moment is not really adequate in a lot of ways. So if you just do the minimum of what's in there, then you may be in a lot of trouble. So yeah, you've got to consider what you're actually putting in these installations. And of course, once you go outside of your house, you can't really bond things because obviously you've got the big mass of earth there itself. So bonding stuff outside, including hot tubs, becomes extremely difficult. So yeah, careful consideration is definitely needed once you're going to start putting stuff outside your house.
Okay, but John, I spy over your shoulder the Code of Practice electric vehicle now. Is this the 50th edition?
Is that a placement?
All right. Is that adequate in your viewpoint with regards to the guidance for electricians?
It's reasonable. It's not perfect because I mean the problem is some of these things will never be perfect.
No.
John, is there any spelling mistakes or typos in it?
Yes, there are.
Oh, great.
Oh, John, there was me about to part my £75.
I say I still haven't parted ways because I'm just frustrated with that specific guidance.
The trouble is, Dave, is it fair to say the industry just wants basic rules of thumb now, rather than that applied thought process? So for me, I mean, my house, I've said this before, and John totally agrees with me, which is one of the reasons why I love him so much, is my earth. When I replace my driveway, I'll be putting a rebar mesh around my house.
Mm-hmm.
Well, with that will go some earth rods as well, and then that will connect, and I will have then just a TT supply into my house. Yeah. For me, that's it. Job done. EV prepared.
I think that's
prepared.
I think that's a great advisory, though, moving forward, because what are the likelihoods of us to knock down our houses and rebuild? Very unlikely. But we're bound to come across customers that are going to have a new bit of driveway done or some landscape work. There are opportunities to get some foundation electrodes installed.
Just to be clear here, this is the first time I've ever had an actual driveway in my life. I've never lived in a house with a driveway. It's a unique privilege that I'm well aware of. So although it is falling apart at the seams, as you're well aware of, Dave. But yeah, so configuration I think is key for safety, and continually applying your own knowledge. Too many people are going on social media asking for a one-stop solution. I had a message today, literally 20 minutes before we started recording this podcast, from a chap going, I've got to do this, and this with EV in a hot tub. What's the solution? And my first step was guidance note. I just want to say guidance note 8, and you, and the local conditions, and the earthing conditions, and the constraints of the installation, and the constraints of the cost, the budget, the consumer. How far do you want to go? Do you know what I mean?
I think unfortunately, a lot of electricians, many of them are actually doing a lot. I mean, whilst I've been doing podcasts with you, my Discord's been popping up. The normal culprits are in there talking about PME and things, so there's guys right now trying to learn, trying to share, trying to move on with this. But many just want to do what we used to do for the past 10, 15, 20 years, is call up a hotline, get a yes or a no, and then hang up. We just don't want to expand our own understanding. We want a yes or a no.
And then they find it weird when they're NIC area engineer or someone else, and they'll stand in front of them and they'll go, yeah, that needs to be earthed. And you'll go, what? What do you mean it needs to be earthed? You mean bonded? Well, yeah, what's the difference? You should know what the difference is. And that's the worrying thing. If you don't know what the difference between those two basic terms is, you definitely need to be going back and doing some seeking and some learning, to say the least. But yeah, so any other thoughts and feelings on? I've done my little railway example. I'm sure there are many others.
I think your railway example is a very valid one, though, because it's very current, it's very present, and that current is not a fault current. It's not a indirect current.
Yeah.
And there's a huge element of risk for people who work on those connections. if they actually, don't understand that technically is a live connection.
It's also
there's energy traveling through that connection.
I think, Dave, there was a chap who on your Facebook group today put a picture of, I think he was doing an EICR. I think it was on your group. He was doing an EICR, and there was DNO cutouts, but they distributed from the cutout a CNE, so it was a combined neutral and earth through the building, which he was looking for advice as to how he codes it. Now, if you come into, like sometimes you'll get like a Ryfield board, there'll be a DNO supply in, say 800 amp, there'll be a load of fuses. Someone had literally run a concentric cable throughout the building, which it's not a DNO issue because the DNO stop at the DNO fuses.
So is that consumer cable?
No, it's like what's the word? It's a private network. I can't remember what the term is. It's something BNO, building network operator. So a building network operator takes the DNO supply and then distribute via a concentric cable.
So does that stay under ESQCR?
It might. It's one of those awful, horrible areas where it could be one or the other or both.
I think we've just opened Pandora's box.
Yes.
But it was a fantastic subject matter on Facebook tonight. Some of those groups, some of those pictures of what people consider to be rough as anything, I genuinely mean this from the bottom of my heart. I have learnt more from crap install and crap work than I ever have good.
I mean, a picture of something that's silly or stupid or bad.
Yeah.
Sometimes it just goes past me straight, but it's often not so much the image, but it's the discussions that go with it, where people go, well, we've done this, or we've tried this, or we've done that. I find that those are a lot more.
But this is the context,
rewarding.
Dave. I genuinely believe you can never make good unless I remember. I swear to God, I remember when I was in Tottenham College and I'd finished my second year and I'd just passed my part 1 because part 1 was 2 years. And I remember thinking, how the hell have I passed this? I have no idea what I'm doing. And I remember somebody said, "Oh, look at that," and everyone was laughing. And it was a picture of some work that they printed, like they went to the shop and got developed. And I looked at it. They handed it round to me, and I looked at it and I went to myself, and I was like, I don't know what's wrong with that. I have no idea what's wrong with it. And I immediately got so upset with myself because I didn't know why it was wrong. So I pulled the guy up and I said, "Can you please tell me why this is wrong?" And he listed off about 30 things. And I swear to God, I never forgot those 30 things because I said to myself, don't let yourself fall into that trap. And that was the first time my brain started, the engine switched on. And I started going, I need to learn more. I need to learn more. So I was starting to open up the books at the section around the photos. And I learnt from what we now define as code breaking. My enhanced learning came from code breaking. And that's why I really get frustrated with people who go, "Oh, I don't want to see pictures of crap work. This industry's brilliant." Yeah, all right. But guess what? Different people learn in different ways, pal. And I learned that way. And I know there are loads of Sparks that learn that way. But we're too bloody proud to admit that sometimes we can look at a picture on Twitter and go, I've no idea why that is the case. And some of the strong ones will go, why? What's wrong?
Yeah.
And it's ever continuous development.
We do it in training, 2391. One of the assessments is an observation assessment. We have to look at illustrating poor work to see if the actual candidates can actually take from those images observations. It's an assessment in the City and Guild course.
Right.
And so one of the great ways to continue that is to carry on doing that.
So when I did my 2391, we had to find, I think it was 15 or 20 defects on a rig. And I got stopped at 42 because I was being so picky. The assessor was just like, "Now you are taking the mick." And he was like, and when I highlighted one, he turned around and he went, "Oh, I only connected that up this morning. Oh, sorry." And I was going, "No, that's loose. That's wrong. That's wrong. That's wrong."
Yeah. So there's supposed to be obviously that rig's a certain scripted rig. There's only supposed to be about X amount on there. But sometimes the technician at the colleges can be a little bit crap. And sometimes they put more in unexpectedly. But yeah, there's that assessment. That's a visual inspection assessment. But there's also, because of the coding, that needs to obviously assess your ability to code. So that came out in the 2395. When 2395 came out, a dedicated assessment of coding came out. And they still use it. There's a download, and they printed out some, I've still got them, X amount of photos, and then some of the photos are red, which means there's a C1 in that photo. Some of them are green, which means there's nothing wrong. Yeah, it's it's been put in there to see if you pick up and you overcode. So some of them have big problems, some of them have no problem at all, and that's used as an assessment. So coding is a great way to maintain your understanding. The only big problem really is, and this is the thing, when I had this chat with City and Guilds about this, the problem is there's no information other than a picture. Yeah, maybe it's a home, maybe it's not a home, but there's no information to actually really support your advice. You can see a problem, but you need to know about the problem to actually properly recommend improvement. And so whenever we ask people, whenever people do submit problems like on the Facebook or so, we don't want to just see pictures, go, this is shit, look at this. We want to actually know where it is so we can actually understand a bit more about it. And then we can obviously offer some more support and some advice on that. And that's just it's the same like with the Codebreaker, the Napier Codebreaker book. Some of those observations have, since it's been published, now been questioned, and now Napier has kind of changed their opinion on some of them. Some codes are one thing, and they're a completely different thing in a completely different environment. Codes change.
I completely agree. I think there is a lot more work to be done on earthing, but I don't think that's just from industry. I think the ones hopefully people listening to this Earthing and Bonding podcast will say there's definitely more work required between the Warren Rigs Committee and the DNO networks, and they need to come to the table and understand each other, because one of the things that I found is the high voltage guys never understand the low voltage guys and their needs, because the high voltage guys are trained as power engineers, not low voltage engineers. So they'll always look for mega fault current dissipation, protection settings. They won't look at LV installations or the requirements for it. They don't care because they assume it's covered. And sometimes, guess what? The two do not mutually interact very well.
BS 7671 gets blamed for a lot of things. A lot of other standards or guidance documents just goes, it should comply with BS 7671, but 7671 in its own box doesn't really cover much.
No, it's not enough. I mean, if you come to I'll use the railway as an example, forgive me everyone, but 7671 is at the bottom of the food chain, along with the guidance notes, because you go above 7671, you need to consider BS 7430, which is Code of Practice for Earthing. You then go above that, you need to consider BSEN 50121, which is EMC on railways. You then have 50122, which is the mutual interaction of AC, DC, and various earthing of railways. Yeah, you've then got electricity at work regulations. You've then got LV directives, EMC directives. You've got network rail standards, RSSB, Railway Safety and Standard Board. So the wiring regs is this trivial, irrelevant, and the worst thing is the amount of times I see bonds, LV bonds on a station that are 10 mil, and you think, well, straight away that whole selection erection process failed. Or it didn't, it just stopped with BS 7671. Perfect example, which we should mention. Lightning protection system bonding, BSEN 62305. I think it's part 3. Sean will kill me if I got that wrong. But in one of our podcasts with Sean from Dane, he actually suggested that it was potentially better not cross bonding the systems. But again, it depends on which lightning protection system you have. The ones where everything is taped and common bonded can actually be more hazardous, because in the event of a strike, it can damage more equipment. The ones with the I can't remember the name of the rods, the lightning conductor rods, you can effectively run them straight via tape straight down and into ground without the need to common bond the main earth terminal to that system. You would still put surge protection in, because surge protection deals with the after effects of a lightning strike, which is the stroke effect, where it dissipates into the ground, can appear on the mains cable as a transient and back into the installation. But it's a safer system,
which is really where it comes into 7671, isn't it? It's the after effect. It's the stroke journey.
It is. That's a great name for an electrical band. The Stroke.
The Strokes.
The Stroke. There's a debut album there somewhere. Yeah, title of a debut album. Right. I think that's about enough on bonding. We've all bonded, chaps.
My recommendation is, if you obviously want to know more about bonding, Guidance Notes 8. You can't avoid Guidance Notes 8. It's a very important book on that one because everyone will point you to that. But go back to the point we said earlier on where we said about value of voltage. You know, we say equipotential at the very beginning is equal voltage. And that means when you go around a place, if you're questioning if there is a need for supplementary bonding, just look at the regulations, go to the Ohm's law, download that document, email Paul for it. You should be able to quantify the value of voltage that would occur in an earth fault. Yep. On a piece of equipment, if someone is simultaneously, and we say they must simultaneously be able to access that exposed conductive part and another exposed conductive part or an extraneous conductive part. If they can, what's the value of voltage? If we can get electricians to the point where they can go around and value or quantify voltages, then it's going to start making a lot more sense.
Yeah, and just as a last tidbit, if anybody wonders what that black cable on the railways is, it's 158 mil square conductor cable, which is made of aluminium. And I would strongly suggest that nobody ever touches it or tries to mess with it, because there will be sufficient levels of energy to cause you quite a bit of harm. On a side note as well, rather than buying books, which we do like buying books, Engineering Design Standard EDS 060017, it's called Customer LV Installation Earthing Design, issued by Eastern Power Network, London Power Network and Southern Power Network, also known as UK Power Networks. It is free, it is up to date with the 18th edition. There is tons of good information in there. We have put some of it in visual form on our Instagram account for your perusal. And I think that's about it, lads, unless you've got any other last words or final thoughts.
No, this is one of those subjects where we can either talk for hours or we just need to call it now, really, I think.
Yeah, let's call it now. Let's call it now. Brilliant. John, I look forward to seeing you doing many an EV charge or a hot tub. I want to see John Moore do a hot tub.
I want to see John Moore talk about that code of practice.
I want to see him talk about that code of practice, and I want to see a hot tub video, and we've got to make this happen. So anyway, right, we're rambling. Thank you very much for listening. Thank you very much for watching.
Cheers, guys. See you.
Please like and subscribe. And until the next one, take care of yourselves and each other. Bye-bye.
Bye.